In today's lesson, we are going to go over limit laws, how to add, subtract, multiply, and divide limits. Welcome back to my channel, Numerics with Nadia, and let's get into our lesson objectives for today. First off, we will define the basic limit laws, and then we will go ahead and apply the limit laws to evaluate limits. If you guys haven't watched my Introduction to Calculus playlist, I will go ahead and tag those videos right here for you guys. I would highly encourage you to watch those before getting into our lesson for today. To start, let's go ahead and define what are limit laws. Limit laws are a set of rules that allow us to find the limit of complex expressions by breaking them down into simpler parts. There are different limit laws for every operation. Let's go through and look at them. Suppose that the limit as x approaches a of f of x and the limit as x approaches a of g of x. Let's suppose that they exist and that c is a constant. If both of those are true, then these are the following limit laws. The limit of a sum is the sum of the limits. So if we have the limit as x approaches a of f of x plus g of x, we would just separate the limits and find the sum of them separately. So it would be the limit as x approaches a of f of x plus the limit as x approaches a of g of x. Same thing for the difference. When we're subtracting, the limit of a difference is the difference of the limits. For multiplying, the limit of a multiple is a multiple of the limit. So if there's a constant being multiplied, you would go ahead and just multiply that constant out. The limit of a product is the product of the limits. So if you have the limit as x approaches a of f of x times g of x, it would just be the limit as x approaches a of f of x times the limit as x approaches a of g of x. And last but not least, for the limit of quotients, the limit of a quotient is the quotient of the limits as long as you are not dividing by 0. And we'll go through here now and do a few examples so we can see how to apply these limit laws. First off, for our example, let's do sum and constant multiple law. Our limit here that we will be analyzing is the limit as x approaches 2 of 3x squared plus 5x. So we know that the sum of limits is the limit of the sum. So we'll go ahead and separate these. We would have the limit as x approaches 2 of 3x squared plus the limit as x approaches 2 of 5x. And how we will evaluate these, we can just plug those limit numbers in. So you'd go ahead and plug in 2 for x. So we would just have 3 times 2 squared plus 5 times 2. We know that 3 times 2 squared just gives us 12 plus 5 times 2 is 10. So 12 plus 10 just gives us 22, and that would be our answer for our first example. Now we'll get into our second example. For number 2, we have one with the product and power law. Our limit here is the limit as x approaches 1 of x squared times x plus 1. So we'll go ahead and separate these as well. We would have the limit as x approaches 1 of x squared times the limit as x approaches 1 of x plus 1. And we'll go ahead and evaluate these two separately and then multiply our answers together. When we substitute the 1 in, we would get 1 squared times 1 plus 1. We know that 1 squared is just 1. 1 plus 1 gives us 2. 2 times 1 is 2, so our answer for number 2 is 2. And now for our third example, we have one with the quotient law. Our limit for this one is the limit as x approaches 3 of x squared minus 9 over x minus 3. And when we have the quotient law, we're going to have two methods of approach here. Our first one is just to substitute directly. So let's go ahead and try that here. So we have the limit as x approaches 3 of x squared minus 9 over x minus 3. If we go ahead and directly substitute the 3 in, we'll have 3 squared minus 9 over 3 minus 3, which would be 9 minus 9 over 3 minus 3. That gives us 0 over 0. When you get this, when you do direct substitution, that means that we have to go to our second method and we're going to have to simplify our function. You can't have a 0 over 0 limit, so now we're going to go ahead and try to simplify it. We have the limit as x approaches 3 of x squared minus 9, and let's go ahead and factor the numerator. The numerator factors out into x minus 3 times x plus 3. that would be over the x minus 3. When we go ahead here, we can see that there is a hole. We'll go ahead and cancel out the x minus 3's top and bottom, and we're left with the limit as x approaches 3 of x plus 3. And now we can go ahead and plug in the 3. We know that 3 plus 3 just gives us 6. So our answer for number 3 will be 6. Now we can get into our last practice question for today. For number 4, we're going to be doing the root law. I know this wasn't in the list of laws, but how would we approach if there is a limit of a square root? We'll go ahead and do that in this last example. We have the limit as x approaches 4 of the square root of x plus 5. Again, for this one, we're just going to try to directly substitute. Let's see how that goes. So when we do direct substitution, we have the limit as x approaches 4 of the square root of x plus 5. That would be the square root of 4 plus 5. We know the 4 plus 5 is just 9, and then the square root of 9 gives us 3. So the answer for number 4 would just be 3. Now I'm going to give you guys a challenge question. Go ahead and solve this in the comments below. For this one, I want you guys to evaluate the limit as x approaches 2 of x squared plus 4x plus 4 divided by x plus 2. So go ahead and try that in the comments. Leave me your answers below. And that wraps up our video for today. I hope you guys enjoyed today's lesson. Please feel free to comment any questions on this topic or any other topic down below. Share this video with a friend, subscribe if you haven't already, and I will see you guys next time.